Welcome back! Today we're talking about security. We will try to understand which security mechanisms are implemented inside the framework. Before starting, let's clarify some basic concepts which are fundamental in order to understand the content of this video. Therefore, let's talk first about authentication and authorization. Authentication is the process aimed at verifying the identity of the person making a request. On the other hand, authorization establishes which kind of privileges someone has. Therefore, which operations can be done and which resources are accessible. These two concepts are connected, but they are different. When I identify a user, and therefore I recognize the user inside the system, this does not imply the possibility to do every operation or access every resource. Each user's privileges are established through the authorization process and the application of rules called ACL, Access Control Lists. In RESTHeart, the authentication and authorization processes are entrusted to appropriate entities called Authenticator and Authorizer. There are two types of authenticators. One of them is based on files, and it's called File Realm Authenticator. The other one is based on MongoDB collections, and it's called Mongo Realm Authenticator. Authorization works in a similar way. In fact, in this case too, we have a File ACL Authorizer and a Mongo ACL Authorizer. Before analyzing the authenticators and authorizers in more detail, let's try to understand how RESTHeart Security mechanism works. Let's take a look at the diagram that we find in the official website. When there is a request from a client, the authentication phase starts. As we already saw, this is used to verify the identity of the user who is making a request, to ensure it's a valid one. We can see here that there are 4 different authentication mechanisms: Basic, Digest, Identity, and Token Basic. The first two, Basic and Digest, use a simple file authenticator. Therefore, they rely on an external file called users.yaml. In this case, there is a list of all the system's users. For each of them, there is a user ID, a password, and a list of the rows, which we are gonna need in the authorization phase. The identity authentication mechanism can be useful in the test phase instead. In fact, it is a mechanism in which a static identity is defined. This means that there is a default user and all the requests are associated to this user. There is no verification of the user's identity. In this way, this mechanism is bypassed and it is only useful in the test phase. The last authentication mechanism is based on token. It uses a token injector, which analyzes the validity of what was passed in the request through a token's cache. This is the typical functioning of an authentication process. When logging in, the credentials, such as user's ID and password, are inserted. The system generates a token, which is then returned in the response. For the following requests, it is enough to insert this token in a proper header, so that the request is validated in the right way. If the authentication phase is not successful because the user was not recognized, the process ends and the response returns the code 401, which means not authenticated. If it is successful instead, we move to the authorization phase. As we already said, the validity of the user does not imply the access to the required resource or the possibility to do a specific operation, such as create, update, or delete a resource. Permits are defined inside the access control lists. For example, using the file-based mechanism, these permits will be specified for each user inside the acl.yaml file. In the future, we will see all this in more detail. So, In this phase, we can have two different outcomes. First, if the user is not authorized to access that resource or to do that specific operation, the code 403 forbidden will be returned. This means that the operation was not successful. On the other hand, if there are no problems, the code 200 OK will be returned, meaning that the operation was completed. Let's now see in more detail the different authentication mechanisms available within RESTHeart. The first one in the list is the JWT authentication, that is the classic authentication based on JSON Web Token. As we can see, the configuration section allows to specify all the parameters which are necessary for the good functioning. These include the indication of the algorithm, for example, the HS256, as well as many others. We also have the indication of the encryption key, the possibility to activate the base64 encoding, and so on, with the indication of the username claim, role claim, as well as issuer and audience, which will be used to manage this mechanism. If we are looking for more details about this protocol, we are sent to the JSON Web Token page. The second mechanism is the classic basic authentication one. This is enabled by default. By default, this mechanism is based on the file Realm Authenticator. We will discuss the file-based authentication in a while. In this case, the authentication is based on sending credentials inside a particular header, the authorization header. More precisely, the format is the following. Authorization is the header. Then, the basic string is specified, followed by a space and base64 encoding of the string that is obtained by linking the user's ID, colon, and PWD, which stands for the password. So, if the user is admin and the password is secret, I will build an admin:secret string. The string is then encoded in base64, and the string we get is linked with basic, leaving a space between the two strings. All this is then passed inside the authorization header. This is a basic mechanism that does not provide any type of encryption. Later, we will look at this in more detail, directly from the computer terminal. In short, we only need to know that this kind of authentication does not provide for username and password encryption. In fact, this is just a coding change. Scrolling down, we have the digest mode. The digest authentication is similar in all aspects to the basic authentication, but in this case, credentials are encrypted. The token authentication is also enabled by default. It allows to substitute the access credential based on username and password with a token that is generated directly by RESTHeart. This token must be inserted inside the authorization header and linked with the user's ID. The string thus obtained is then encoded in base64. We will also see an example of this mechanism on the computer terminal. In short, this is what we must remember. If we succeed in doing a basic authentication through our username and password credentials, a token is returned. We will be able to use this token for the next requests by following the scheme we just saw. We will substitute the password with this token. In this case, the token is generated randomly through Round Token Manager, but we will talk about this later. Finally, we have an identity authentication. This is a peculiar mechanism because it is a way to bypass the authentication phase. In fact, a basic account is created with its username and rows which are specified inside the configuration. This mechanism is disabled by default because it conflicts with the others. So, as we can see, from a configuration point of view, we have a user. In this case, the user is admin, and its roles are admin and user. This means that all requests sent to the server will be associated to this user. So, there is no way to check the credentials to establish if the user is a valid one or if credentials are correct. This is useful in a testing phase to check if the access to specific resources is correct. Where there are resources requiring an authentication, we can check if they are accessible through a particular authenticated user, without going through the entire credentials verification process. Now we move on the terminal to check how clients can authenticate by doing some tests with curl. Curl has an option which makes it possible to specify username and password. This is curl --user. We use the admin default credentials, admin:secret. And then we specify the server's URL, that is localhost:8080. Let's add a couple of options, -v and -i, so that we can see the request and the response, and in particular, the headers which are exchanged. Here it is. The request was successful and we got a 200 OK code. It is interesting to see that the --user admin secret option has turned into the authorization basic space header, plus the string which is apparently incomprehensible. In short, this authorization header was passed inside the request. As we said, this is a basic authorization. This string corresponds to the base 64 encoding of the admin:secret string. But be careful, this is not the string's encryption. This is simply a string in a different encoding. In fact, from this string, we can have these credentials back with a very simple operation. If we write echo, then we copy the string and pass all of that in base 64. With the decode option, the credentials admin:secret are returned. So, the basic authentication does not offer a safe protection mechanism at all. It simply changes the encoding, but credentials are still visible. This means that all communication should not take place on the HTTP protocol, but on the HTTPS, which is a safe channel. This would prevent the string from being intercepted. In fact, if that would happen, it would be easy to find the credentials. What was returned to us is the list of the collection found inside the database. What we did was a get on the root. The list shows ACL, inventory, and users. Inventory was created in the previous experiments we did with REST Ninja in the first video. On the other hand, ACL and users are the two collections used by default by MongoDB to manage users and rows. Inside the response, it is interesting to see the token called auth token. This string was generated by the server starting from the credentials. This token can be used in the next requests. So, instead of passing this string in the authorization header, we can pass this token. Let's now see a practical example. After cleaning the screen, let's see how to use the token in our request. First, the classic request with the admin:secret credentials. This way, we can get the token again. Now, let's see how to use it. We have to link the token with the user's identifier, create a base 64 string, and pass it in the request authorization header. Let's move step by step. The first step is to create our string in the base64 encoding. We use echo-n so that we can remove the new line character, which will be automatically added at the end of the string. As already said, the token must be linked with the admin:username. Then we pass this string in base64 and we add the WO option so that we have only one sequence. Now we copy it. Let's clear so that we can work more easily. So, we add curl -v -i. In this case, we must pass the header, so we add -h. The header is authorization:basic. There is a space and we paste our string here. Then we must call http://localhost 8080. Good. As we can see, the server responded without any problem. In this case, we use the authorization token that RESTHeart returned, instead of using the classic user ID and password credentials. This is the mechanism that will be used in the applications to communicate with the server. So, there is a first login request in which we pass the credentials, and then we use the token returned by the server for the following requests. Let's now see an example with the identity authentication mechanism. Let's clear the screen again. To enable this mechanism, we must make a small change in the configuration. This is the list of the configuration files. We must act on restart.yaml. So, we can go in the section dedicated to the authentication mechanisms and we deactivate the basic one by adding false. The one based on JWT is already disabled. We must disable the digest too to avoid conflicts. Then, we must enable the identity mechanism by adding true. As we can see, here we have the admin user, with its usual admin and user rows. So, let's work on an example to see what happens. Right now, we have the file-based basic authentication. So, if we make a call but we don't specify the credentials, we should get an error. In fact, if we add curl -v -i and we call http localhost 8080/ without specifying the credentials, we get the error 401 not authorized. Let's zoom in. Here it is, 401 not authorized. We will see now that by enabling the identity, we will get a different response. Firstly, we must save our configuration file and shut down RESTHeart. We reboot it so that the new settings are loaded. After a few seconds, we are ready and we can go back to the page where we got the not authorized error. If now we execute the command again, we get a 200 OK code. What happened in this case? Well, since we enabled the identity authentication mechanism, it is as if the request came from the admin user by using its credentials. We bypassed all the authentication procedure and we got a positive response from the server. This mode is to be used only in the testing phase because of security reasons. Let's now take a look at the authenticators. As we already said, we have two different authentication mechanisms. One of them is based on files, while the other one on MongoDB. Even if on the website they appear in a different order, let's start from the file-based authenticator, which is probably the easiest to understand. Let's move on the RESTHeart.yaml file and let's go on the section dedicated to the authenticators. They are both enabled by default. The enabled file-based authenticator, which is shown as File Realm Authenticator, relies on a configuration file. Inside this configuration file, we find all the system's users. By default, this file is called users.yaml and is found inside the etc folder. Let's take a look at it in more detail. As we can see, we have a structure where all the users are listed. For each of them, we can see the user ID, the password, and the rows array. In the example, there are two users. One of them is simply called user. Its password is secret and it has the user role. The other one is called admin. Its password is secret too, but this one has two rows, the user and the admin rows. Later, we're going to understand the meaning of the rows better. For now, we can say that the rows are used to define which resources the different users can access to. The second authenticator is based on MongoDB, and it is shown as Mongo Realm Authenticator. This is the suggested solution in a production environment since it ensures more file management protection. This happens because the passwords are encrypted. The data are contained inside proper collection in the database, and it is possible to add, delete, and modify new users through API calls. Talking about configuration, we can see that we have more properties compared to the management through file. This happens because configuration requires the fine-tuning of different aspects. Let's see them one by one. First, we have the user-db set on restart. The values we see here are the default ones, and we find them with the first installation. Everything can then be easily set up by modifying the configuration file itself. So, the default database is obviously restart. Users is the collection which will contain all the documents related to the different users. We can also specify the fields intended for the identification of the user and the password. In this case, we have the _ID and the password fields. They will contain, respectively, the user identifier and its related password. For what concerns the rows, the path.json is specified. We also have another property, the bcrypt hashed password. This allows to memorize the password in a safe way, and we can also specify the complexity. Another very interesting aspect is the create user. This is enabled by default and, when it's enabled, it allows the creation of a user at the first launch. To be more specific, it allows the creation of an admin user, which can then be used to execute all the system management's operations. As we can see, a user is created. Admin is its ID, and secret is its password, which has been encrypted with bcrypt. Then, we can also see that it has the admin role. Of course, we can change both the user's name and the password. For example, we can choose a different name such as administrator or root. We also have some settings related to the cache management, which in this case is disabled. We have the cache's dimension and the TTL too, that is the cache's time to live. we can also establish the politics. This means that the TTL can be calculated starting from a specific moment, for example, after a write operation. Finally, let's talk about the token managers. They are used to generate the authentication tokens which can be used instead of the username and password credentials. The token manager is based on a random number generator and it has a 15 minutes TTL. This means that the generated tokens are valid up to 15 minutes. We also have an endpoint, which in this case is called /tokens, which allows the invalidation of the user tokens. Therefore, a request on this endpoint allows to invalidate the token. Now, let's take care of the authorization, which can be done through two different authorizers. One of them is based on Mongo, while the other one is based on files. Let's start from the one based on Mongo. This works like this. We have a MongoDB collection, inside which some documents defining the access control lists are saved. The access control lists are the lists defining the privileges for the different systems users. Let's see in more detail the part related to the configuration. It's similar to the one we already saw in the authentication part. So, we have the indication of the database, which by default is RESTHeart. We also have the indication of the collection dedicated to the ACL, which is called ACL. Then, there is a root role, which in this case is the admin. This means that this user can execute every kind of request, regardless of the permits which have been specified inside the ACL. To deactivate it, we can set the value to null. We also have the chance to manage a cache with the dimension, the TTL, and the expiry policy, depending on the fact that this does or does not happen after a collection modification. Let's take a look at the document's format. As we can see here, we have the classic Mongo document. There is a predicate, as we will see in more detail. There can be a rows array, a priority, and read and write filters. In fact, the main properties are shown. We can already say that the predicate is based on the undertow syntax, which is the server RESTHeart is based on. It is an alternative to the best-known Tomcat. This is the documentation page instead, where the syntax is described. It is full of information, so it takes quite some effort and study to master it. As we can see, these conditions can be linked. In fact, we have the AND and the OR operators. Moreover, we can also see that an editor can see the posts whose author is the authenticated user. This percentage user indicates the user who was authenticated at that time. Finally, the status is published. This means that it will not be possible to see the drafts of the post. In the right phase, it will be possible to act only on the posts whose author is the user that is authenticated in that specific moment. Of course, this is done to filter the data according to which user is authenticated. In fact, here we can see more details about it. The file-based method, which is the file ACL authorizer, does not use a Mongo collection but a file. From a configuration point of view, it is enough to specify this YAML file. This is the default path and this is its default name, while this is its structure. In practice, we have the keyword role followed by colon and the role itself. Here we have the rows' names, such as admin and user. We also have a particular role called $unauthenticated. This specifies which operations can be done by an unauthenticated user and which can be done by the users according to their roles. So, we simply find again what we previously saw. For example, that the unauthenticated user can access the /echo endpoint and make GET calls. We also see that the admin user can access everything. On the other hand, the user which is simply called user can only do a limited number of operations, such as accessing /echo or /seco, making put calls, and so on. As we can see, it is possible to specify the permits in a very detailed way. So, not only from the endpoint level, but also for the specific calls, with all the conditions which can be linked. In this way, it is possible to better manage and filter the data, and thus ensure the highest security level. Now, let's take care of the user's management with reference to Mongo Realm Authenticator. First, let's move on the terminal and let's enable the authentication mode based on MongoDB. We write nano restart.yaml. Now, we go in the section dedicated to the authentication mechanisms. We use the basic authentication, but we change the authenticator and we add Mongo Realm Authenticator. We do the same for the digest and we save. Now we can start to restart again with the new settings. If there are no problems, it should be active in a few seconds. Here we are. Now we can go back to the terminal. In fact, we will make our tests by using RESTNinja with the codes already available on the official website. This is the page, that is the user management. First, let's see how a user document is made. Basically, the document representing a user contains the _ID field with the username, a rows array, and the password, which in this case is secret. Of course, as we previously saw, we can change both the user and the password identities. Now let's see how it is possible to recover the users list. The users list is saved by MongoDB in the users collection. Basically, we must make a get on this endpoint. We execute RESTNinja, which is already setting up the get and the endpoint to be called. Now, we go in the basic authorization, where the credentials are already inserted. So, if we make the call, the admin user with the admin role is returned. Let's remember that compared to the file-based authentication mode, where inside the users.yaml file we could find both the user called admin and the one called user, in the MongoDB-based mode we only have an admin user with password secret, which is automatically created at the first start of the instance. This happens in order for us to have a user that can execute some operations. Something very interesting to notice is that the password is not returned inside the document. Despite the password is saved in an encrypted manner with bcrypt, the field is not returned. Another interesting thing is that it is not possible to use filters in the password property. For example, we could try to apply a filter in order to bypass the protection. Let's see what happens in this case. We go to RESTNinja and make a small change. By default, the password property is not returned. However, if we apply a filter, we can see that some documents are returned, which are based on the password properties filter. The answer is 403 forbidden. This shows that it is not possible to apply filters on the password property. This represents an additional protection mechanism. Now, let's see how to create a user. In this case, we must make a post on the /user endpoint, and in the request body, we must add a JSON object which is made like this: an identifier, a list of rows, and a password. The password is plain text now, but then it will be saved inside the database in an encrypted form. This helps us understand how important it is to have a safe connection between the client and the server, since the request password is in plain text and could be intercepted. We execute RESTNinja and we see that it helps us in the operations. In fact, the body and the authentication are already set. We have this user called foo. Let's change the name in Mauro. We execute it and we get 201, telling us that the resource was created. Now we make a get again, and we can see that we have the two users. The user Mauro was added to with the user's role. On the other hand, to update a user, we can make a patch on the /user/endpoint, and here we must indicate the user. Then we pass the password, which also here is in plain text. In our case, our user is called Mario. Let's just leave better secret here. And now we change the password. So, since we changed the password of the user Mauro is now better secret. If you want to delete a user, we can make a delete on /user/ plus the name of the user. Let's take a quick look. We delete the user Mauro and we execute the operation. We get 204, which means that everything is okay. Now we see the list again. We change from delete to get, and now we only have the admin user. Finally, let's see how to make an ACL document, which, as we already know, is an access control list. We make a post on /ACL and we pass a JSON document with this structure: the predicate, the rows array, the priority, and the eventual read and write filters. Let's try to do this operation. Okay, the operation was successful. In the documents, we are reminded that if the /ACL collection was not previously created, we get a 404 not found error. Therefore, we must initially create the collection with a put on /ACL. This is an operation we already executed during the tests. At the end of this extremely long video, I leave a link to an application example. This is a blog which can be found on the project's official repository. This is an application written in Angular which simulates a simple blog and which can be used to test everything we talked about in this video. I quickly show you the part related to the authentication, which is the object of this video. So, there is a login form with fields related to username and password. This login function is recalled by the sign in button, which is found inside the JavaScript file. As we can see here, the form's credentials are recovered. They are coded in base64, and the command line authorization header is built as we saw in the example. Then, the call is done on the /rows/user identifier endpoint. In case of a positive response, the token is recovered and the credentials are saved in the local storage. The application is working, and therefore it can be tested, studied, and modified to better understand the authentication operating mechanism in RESTHeart. This is all for now. Thank you for watching and see you in the next video for more insights.